All right, so I just wanted to thank everyone for joining us today. It's really awesome to be back again in person, at least for me. It's been a lot of fun seeing everyone and being in person for conferences again. You know, TSA lines are back and jet lag is back and all that good stuff. But today we have a really fun session for you. We're going to be talking about Google Kubernetes Engine and why it should be your enterprise compute platform of the future. My name is Victor Szalvay. I'm a product manager. I work on Google Kubernetes Engine, or I'm going to be calling it just GKE going forward. I'm joined by some colleagues to my right here. Sean Derrington. Sean is the group product manager, outbound product manager for the storage space. And we're really excited to be joined today by Jumpei Nakajima from Capcom, who flew all the way here from Japan. So Jumpei will be speaking today in Japanese, and he's joined by translator Mika at the end. All right. So containers and Kubernetes, right, have really been taking the world of infrastructure by storm. It's been providing on-demand scalability, efficient resource utilization for a range of applications from, of course, your modern apps, which I think most of us associate containers and Kubernetes with. But that's been expanding, and it's been extending to things like batch. And of course, you've been hearing about AI, ML. Of course, games. And even things like legacy enterprise applications are now being run in containers in Kubernetes. And Google open sourced Kubernetes back in 2014. And in doing so, we basically built the world's largest ecosystem around containers. And if you think of containers then as a specification or a standard for running containers, this means that your workloads are highly portable. But in addition to the portability element, it's also created an ecosystem, a huge community of open source and commercial vendors that are building and greatly expanding the value proposition of Kubernetes. So today, Google remains really strongly committed to Kubernetes. We are by far the largest contributor to open source Kubernetes. And beyond open source, GKE really leads the pack as the most automated and scalable managed Kubernetes platform on the planet. We support up to 15,000 nodes per cluster, and there are customers doing things like virtual supercomputers in their clusters. They're of course also doing large-scale LLM model training and so forth. So why GKE? And it turns out that do-it-yourself Kubernetes is often really challenging, right, in the form of a high degree of expertise required. It's also very labor-intensive. So your day two operations, the labor effort required there is very, very high. So what we're trying to do with GKE is preserve the spec, the open source spec, as much as we can, while providing additional management capabilities to alleviate that burden and manage it for you, right? And so this is things like, for example, upgrade management, right? New releases of Kubernetes come out. So we help with upgrade management. We help with things like automated backups, which Sean's going to talk about, automated node scaling. And all of this greatly reduces your day two operations toil and gives you the control you need to be able to run your business the way you want to run it. Security is another aspect of Kubernetes that we really lean into, right? So out of the box, we bring a baseline, foundational Kubernetes security posture and best practices, alerting, all of that comes out of the box. In fact, we work at every layer of the stack, from things like hardware, of course, to the virtualization tier, to things like OS. We built a custom OS for running containers effectively and safely. And of course, Kubernetes itself to provide that comprehensive security posture. I think when most people think of Kubernetes, they think of scale, right? And of course, Kubernetes and GKE scales to meet the dynamic needs of your business and at the time for that workload. So that alleviates a lot of the work having to do with manually scaling up and manually scaling down. Instead, you can automatically have GKE provision your infrastructure on demand and then watch it scale down when it's not needed. And all of this comes with the reliability you'd expect from a company as committed to containers as Google is. So I don't know if you all know this, but almost everything at Google runs on containers. So including search, Gmail, YouTube, and so forth. All of those services all run on containers, and we've been running containers for a very, very long time. And so it's not just the technology, but it's also our engineers, our SRE teams, and so forth. We're a completely container-first organization, and that provides us with a tremendous advantage when it comes to actually operating and running GKE as a cloud service. Now, in addition to the cluster level capabilities that I've just talked about, you probably heard that this week we announced GKE Enterprise Edition. And this is really exciting because, sure, we have a lot of services around the cluster, but what about if you have 10 clusters, 30 clusters, 100 clusters, 1,000 clusters? It starts to become very challenging to manage them at scale. So we've introduced additional capabilities like fleets and teams, which allow you to define scopes and basically keep everything synchronized across regions and also consistent, right? And this is all packaged with security in a well-integrated format. Okay, so what can you do with GKE, right? There's, of course, modern applications, and I think everybody kind of, again, thinks of that as the first thing. Hey, we're gonna run some microservices, we're gonna build something new. Let's use kind of this sort of architecture and containers and so forth. But there's actually a whole lot more to it than that. GKE is being used for a number of things, including stateful and legacy. Folks are running databases in GKE. And Sean's gonna be talking about this quite a bit, but that's really helped by the notion of automated backups that will snapshot your persistence layer, safe blue-green deployments, and an extensive selection of storage, right? Storage options. And again, Sean, toward the end of the presentation, is gonna get into this in much more detail. And then, of course, you may have heard that this year, AI ML is pretty big, right? Vertex AI is, of course, our recommended managed solution for AI ML. But it turns out GKE is also an amazing platform for AI ML. And that's because it blends, ideally, the ease of provisioning of hardware accelerators like GPUs and TPUs. It blends that with capabilities like compact placement and highly efficient utilization of resources, resource sharing, GPU sharing, and so forth. And this is often needed when you want more control, right? Such as if you're training your own models and so forth. And in fact, I mentioned this earlier, many of the largest LLM models today are being trained on GKE. The last one I'll mention is games, and of course we're gonna talk about games in a lot more depth today. For the gaming perspective, especially live service games, they're also thriving on GKE. And in large part because of the elastic scalability, meaning the unpredictable demand of when people are playing the games, coupled with the fact that it's highly cost efficient, and we're able to reduce the management overhead associated with managing all that infrastructure. So let's dive into games a little bit more. I'm going the right direction here. So at Google Cloud, we're actually building a platform for live games. And this unifies performance with analytics. So we've identified 3 critical areas for games. And we're gonna talk beyond GKE a little bit just to paint you kind of a broader picture. And Nakajima-san is gonna be talking about a specific implementation that Capcom did of this particular stack. So starting with the game servers, this is the technology that brings together players from all over the world into a common real-time experience. We've open sourced the Agones server, which is a game server, and it runs really brilliantly on GKE, and it scales very well on GKE. Next up are databases. Cloud Spanner tends to be the database of choice there for its massive scale and global footprint. And then, of course, there's analytics. You want to know how your players are feeling about the game and feedback and so forth. So BigQuery and Vertex AI combine really well there to allow companies to understand that business dynamic and what's happening with the players, right? So do we have any gamers in the audience? I know there's got to be some gamers. Yeah, okay, awesome. I remember playing Street Fighter in the arcade when I was a kid, spending most of my allowance on quarters into the arcade game. So you've probably heard of Street Fighter as well. It's a massively popular live game. And it runs on Google Cloud. And it's including, and that includes, of course, GKE for the compute layer. So please join me in welcoming Mr. Jumpei Nakajima, technology lead for Capcom's blockbuster live game, Street Fighter 6.
Thank you. よいしょ。OK。日本語で失礼します。カプコンから来た中島と申します。はい。ストリートファイター6はグローバルに展開されるサービスであり、GKE 上に展開されているマイクロサービスで提供されています。はい。各サービスは gRPC を通してお互いに連携を行っており、それらのトラフィックはアンソースサービスメッシュによって制御されています。はい。
Good afternoon. My name is Nakajima, and I am from Capcom Japan. Excuse my Japanese. So Street Fighter 6 is a global service offering, and it is built on a microservices architecture deployed on GKE. The services are interconnected through gRPC, and their traffic is controlled by the Anthos service mesh.
データベースには、Google クラウドスパナーを使用しておりまして、一過性を保ったまま、大規模なスケール展開をしています。
So the database is Cloud Spanner, which allows for massive scaling while maintaining consistency.
はい。そして、実際のプレイヤー同士の、戦い、対戦は、サーバーでマッチングを行った後に、クライアント同士のピアツーピアで、対戦を行っております。
Then after matching of players is done on the server, the actual games are played peer-to-peer between clients.
はい、これは、格闘ゲームっていうのは、レイテンシーの要件が、とても厳しいので、一般的に使われている、リレー形式では、それを満たすことができないからです。
This is because fighting games have strict latency requirements that cannot be met in a relay format.
はい。これは、ストリートファイター6の、ネットワークインフラ構成図です。
So this is the diagram showing the network infrastructure configuration for Street Fighter 6.
はい。クラスターは、主要4リージョン、US セントラルと、サウスアメリカ、そして、ヨーロッパとアジアに構築されています。
Clusters are built in 4 main regions: US Central, South America, Europe, and Asia.
はい。そして、ここの、アクセスが出ている線なんですけれども、どのリージョンからの、アクセスであっても、HTTP リクエストは、必ず同じクラスターに、通信することが、通信がされます。
Regardless of which region you are accessing from, HTTP requests are always made to the same cluster.
そして、WebSocket による通信は各リージョンごとに、構築されたクラスターに対して行っています。
The WebSocket communication is then performed by the cluster built in each region.
はい。ここで重要なのは、各種、GCP へのサービスへの線が、HTTP を受けているクラスター、US セントラルに立っているんですけれども、メインのクラスターからしか、各種の Google のサービス、GCP のサービスにアクセスしていないというところです。
What's important to note here is that the access lines to the various GCP services only extend from the main cluster, which is US Central. that receives the HTTP requests.
はい。そして、それ以外のクラスター、メイン以外のクラスターからは gRPC のアクセスの線が伸びていて、それらはすべて US セントラルのメインのクラスターにつながっています。
Other clusters have gRPC routes that lead to the main cluster, which is US Central.
つまり、メイン以外のクラスターは、gRPC を介してメインのクラスターに処理を依頼するだけで、実際のデータのアクセスであったり加工というのはメインのクラスターからしか行われていないということですね。
So the non-main clusters ask the main cluster to process the data via gRPC, and the actual access and processing of the data is only done by the main cluster.
マルチクラスターメッシュの構成を詳しく見ていきましょう。
Let's take a closer look at the multi-cluster mesh configuration.
HTTP リクエストは、どのリージョンからでも US セントラルのメインクラスターが引き受けるというのは先ほども説明しました。
We have just explained that HTTP requests are taken care of by the main cluster built in US Central from any region.
アクセスを受けるロードバランサーは、グローバルに設置されていますので、各リージョンからのアクセスは、アクセスのレイテンシは、最適な経路を通り平均化されます。
The load balancer that receives access is installed globally, so the latency of accesses from each region is averaged through the optimal path.
はい、ここは、GCP さんの、高品質な回線網に助けられているところですね。
This is where GCP's high quality network is really aiding us.
はい、このような経路を取ることにより、データアクセスの経路を、統一することができます。
This way, the path of data access can be unified.
はい、ちょっと小さくて見づらいんですけれども、赤く引かれた、線が1本だけ伸びていると思うんですけれども、これは、メインリージョンからしか伸びていません。これは、繰り返しになってしまうんですけれども、データのアクセス、加工、サービスへのアクセスっていうのは、メインクラスターからしか行われていないと、唯一の経路であるということです。
Sorry, it's very small on this chart, but there's a little red line, and this line is the only access path to the various resources. Basically, it means that only the main region would process the data, and this line does not extend outside of the main cluster.
はい、こうすることによって、データがリージョンごとに散らばってしまうことを防ぎ、どのリージョンからアクセスしても、統一のレイテンシーで提供することができるようになります。
This way, user data is not scattered across the various regions, and only latency remains constant no matter where it is accessed.
はい。しかし、WebSocket のアクセスは、各、クラスターに伸びていますね。これは、バトルハブサーバーというものが、ソリッドファイター6にはあるんですけれども、いわゆるビジュアルロビーサーバーのことです。
ビジュアル
ロビー。
ビジュアルロビーサーバー。
ロビーサーバー。
ビジュアルロビーサーバー。Okay. So this means that the data access is so this way the user data is not scattered across the various regions, and latency remains constant no matter where it is accessed. However, you have WebSocket access flying to each region's cluster. These are the Battle Hub servers on the Street Fighter 6, and basically this is a visual lobby servers.
はい、これは、オンラインロビー、ビジュアルロビーは、最大100人のアクションを同期する必要があり、レイテンシの要件が厳しいため、物理的に、近い、クラスター、リージョン、サーバーに、接続する必要があるからです。
So such visual lobbies need to synchronize the action of up to 100 players and need to communicate with regions that are physically close to each other due to strict latency requirements.
はい。しかし、バトルハブサーバーも、基本的にはアクションの同期通信しか行っておらず、データの操作であったり加工はメインクラスターに対して gRPC を介して依頼します。
However, the Visual Lobby servers are basically only performing the action synchronization communication, and the data operation is requested from the main cluster via gRPC.
はい、これもデータのリージョンの分散を防いで経路を統一するためですね。
This is also to prevent the scattering of the data and unify the data access route.
はい。そして、これらのアクセス、gRPC を介したアクセスはすべて、アンソスサービスメッシュのマルチクラスターによって、ごめんなさい、マルチクラスターメッシュによってクラスター同士がつながれており、インターネットを出ないことによって、Google の内部制御を通ることによって、はるかに高速に、接続することができています。
This access path, which goes through gRPC, is constructed by multi-cluster mesh of Anthos service mesh, which goes through GCP's internal line. It doesn't go out to the internet, which actually allows for much faster communication than using the internet.
はい、以上です。簡単にはなりますが、アーキテクチャ部の説明をさせていただきました。ありがとうございます。Thank you.
That is all for my presentation. That was the brief explanation of the architecture. Thank you very much.
Thank you, Nakajima-san, for sharing your experience, and congratulations to you and the team for Street Fighter 6. That was fantastic. So, as you heard Victor say earlier, Kubernetes and GKE has been around for a long time, and many enterprises have been deploying stateless applications on GKE, and that's perfectly fine to do. However, as more companies are deploying stateful applications, some of the more traditional enterprise applications are being migrated and deployed on GKE, and that changes the way you have to think about managing those services, because things like backup now become important. There are other things around storage that's also important. But regarding backup for GKE, this is something that we launched last year at Storage Day and Next, the virtual Next last year, and that has been generally available for over a year now. We're proud to be leading this, and this is now generally available as a fully managed service for you to deploy and protect your clusters. And this is a differentiator for Google Cloud. As you look at the different reasons and the capabilities of being able to now protect cluster configurations in a very automatic and consistent way. It gives you a very granular option to deploy backup for GKE to protect the cluster configuration, your namespaces of choice, application consistent backups, and or data that's used by GKE. So if you have persistent data that needs backing up, this is a fully managed service that you can take advantage of. It's one of the things that allows not only the recovery of the data in the event of data corruption or human error, but one of the things that a lot of our customers are using this for, more so than protecting the data itself, is actually the cluster configurations. And that gives you as developers in DevOps the opportunity for very easy and consistent rollbacks for errors that happen, unfortunately, very, very frequently, right? So as you're upgrading the clusters, if that happens, you have a run into a problem, you can roll back that cluster configuration very seamlessly. You also have the opportunity, most GKE clusters use persistent disk or block storage. Others use file systems, and I'll talk to that in just a moment. But backup for GKE also gives you that opportunity to use and protect the data stored on persistent disk. It gives you this flexibility to store and protect the cluster configuration and storage in a specific and retention lock period. So what this means is, for a given backup policy, you can define what cluster configuration you want to protect the data, and you can set a specific period of time that that backup is immutable and indelible. So you can set it for days, weeks, or years if need be. And what that means is that whether it be human error or ransomware that compromises and tries to compromise your data, that backup is secure. You as an admin, and even as a super admin privilege, cannot change the backup policy. You cannot delete that backup, nor can you even delete the entire project that that backup is protecting once that retention lock, until that retention lock period actually expires. So It's a great thing to protect that backup for that retention lock period, but also from an administration standpoint, if you set it for a year and you want to change that period to 3 months, you now have 9 more months to wait until that 1 year expires. So take that into account as you're setting those retention lock periods. But this is also one of the things that allows you a lot of flexibility to protect those resources and data as I described at a very granular level and recover clusters in the same region, either to the new or existing cluster, or as a migration opportunity, if you're moving from US Central 1 to US East 4, you can use this backup and recovery process to actually recover and create new clusters in different regions very seamlessly with the exact same configurations that you used in the original one. So very flexible to do, but as I mentioned earlier, this is one of the things that's a little bit surprising in that customers use backup for GKE to protect the cluster configuration as a larger percentage than actually protecting the data itself. So you can use it in a variety of ways. Cyberhaven will be talking in a session around backup recovery, how they're able to actually recover their data 24 times faster with backup for GKE. They have the confidence in their DevOps process, and for regulatory purposes, the backup vault and that retention lock period that I was describing is one of the things that helps them satisfy their compliance requirements. So you can hear more from Cyberhaven in that session as well. Storage is one of those things that a lot of times has been an afterthought for GKE, or just deploy persistent disk and you're done. However, you heard this morning from Thomas and Sundar that 70% of the unicorns today are using GKE, right, and are using Google Cloud in general. And a lot of those training models actually require or prefer file system access for training. They can't be refactored either from a cost or time standpoint. They can't be refactored to use object storage, or maybe it's a latency requirement. And if you don't use file systems, now you avoid having data cached locally in the pods and the clusters, but you also have idle GPU and TPU cycles waiting while you're extracting from object storage, loading into the containers, and then beginning the training. So there are a few options you can look at. One is NFS storage. The other is POSIX, right? These are full file system semantics access, multi-writer use cases. You also have the option for Fuse, which has been open source for over 10 years that you can use with object storage. And that gives you essentially the file system access to a bucket, right? And in all three of these scenarios, whether it be Fuse, POSIX, or NFS, it's all maximizing your GPU and TPU cycles because it's a file system that's immediately available for training. And so what we announced last week, and is generally available now, is Cloud Storage Fuse. This is a fully managed Fuse offering that you can use from Google Cloud. It's also free of charge, but you can now mount your buckets like they were a file system. It provides that file system semantics, but it's not full POSIX compliant. So there are some caveats, like multi-writer support and things like that, but you have the ability now to have your massive scale models, petabytes, et cetera, immediately mounted to GKE through the CSI driver. Use your PyTorch and TensorFlow workflows to do this, and it provides massive scalability and massive performance. We have customers today exceeding 30 terabytes per second of throughput with cloud storage in their training. Not everybody's going to be at that scale, and that's perfectly fine, but it is one of the things that now gives you more opportunity to deploy a fully managed service in the packages that we actually provide. We have a number of images that you can use, or you can do it yourself as well. The other thing that we announced last week was for file systems, and in this case, training models, that need ultra-high performance and multi-writer support. And that's where we introduced Parallel Store. This is currently in preview. This is another newly introduced Google managed service. It's a parallel file system. So now it's actually built on Intel Deos's open source cloud-based deployment model. It's a key value store, so it's very cloud friendly in terms of massive scale, in terms of the number of nodes, capacity, et cetera, that you can do. But it's one of the things that actually maximizes the GPUs and TPUs as well, because every pod and cluster has equal access to the data. It supports full POSIX. It's a parallel file system, but it's also ultra high performing and provides ultra low latency. So in this case, you can see that we're 6.3 times faster than other Scratch Lustre deployments, and we actually can exceed terabytes per second of throughput with millions of IOPS and 0.3 milliseconds latency. Okay, very different contrast to cloud storage, different purpose, but it's another option for a given training model that you have. We have also integrated erasure coding in the back end to protect that data from if a node goes down or data volume goes offline, that persistent volume is actually protected via erasure coding. So these are two of the options that we've recently introduced. Cloud storage Fuse is GA, Parallel Store is in preview, and Filestore is a third option for NFS, for GKE. There are two different Filestore options, Filestore Enterprise, or actually three I should say, Filestore Basic, Filestore Enterprise, and Filestore High Scale. They each have different features and functions. I'm not going to go into all the details in this session here, but these provide the option to use different performance levels, capacity levels, availability, and pricing for GKE. Filestore Enterprise, we've recently enhanced the multi-share capability. For those that are using Filestore Enterprise multi-share, you've been used to this at 100 gig persistent volume. You can now get down to 10 gig capacity per persistent volume. So again, it's an NFS share. It's available to hundreds or thousands of pods in a given cluster. It has multi-writer support, so every pod knows exactly what file they're opening and closing and writing, and you're not going to compromise your data from that perspective. So it's a great way to have a scalable way for not only the data to be accessible across all pods, but if pods go down, the other pods still have access to the exact same data, and your applications just continue to run. I mentioned the differences in Filestore between Basic, Enterprise, and High Scale. Enterprise has a 4.9 SLA associated with it, which means that it actually deploys the storage in 3 zones within a region and synchronously replicates every single write across all 3 zones in a given region. So now you're protected from a zonal outage. And if your architecture is such that you want to do the compact placement that Victor was talking about in different zones within a region, you can also match that availability with the storage of Filestore Enterprise. Backup for GKE, I described how that can protect data, the persistent data that you want in persistent disk, as well as hyperdisk, but just the block storage of persistent disk. That will also support Filestore in the near future. In the meantime, what we have coming next quarter is the ability to just use Filestore Basic, Filestore backups to protect either the entire instance or multiple shares. If you're using the 10 gig persistent volumes, you can have that level of granularity. 2 different ways to protect the Filestore data based upon the Filestore tier that you're deploying, and that'll be available next quarter. Shortly after that, we'll be supporting backup for GKE, so you can use the backup vault and the retention lock in the same granularity and policy-based protection. In the meantime, you have another way to protect the data until backup for GKE supports Filestore. So we've been expanding our file offerings, not only for AI and ML, but obviously for other HPC workloads and other general compute workloads. But this is a way you can kind of think about your training model needs, whether it be text or video and image. And it's not a one-size-fits-all, right? You can choose the right storage for different models and pick and choose. On the far left, you have the option for ultra-low latency, very high IOPS, file sizes that are in the kilobytes or tens of megabytes or even 50 megabyte range. That's great for parallel store. It's a great solution for a parallel file system, maybe also Filestore, where maybe you don't need the terabytes per second, you don't need that massive scale, you can choose something in the middle. And on the far right, when you look at cloud storage, you can choose this now with Fuse as a file system interface for your training model needs, but it gives you that still very high throughput, lower latency, because it's regardless of the storage bucket you're using, the storage class, it's still milliseconds of response times, or maybe tens or hundreds of milliseconds. Whether it be standard or all the way down to the archive storage class with cloud storage, you're still talking milliseconds. It's not minutes to hours to days as some other solutions have, right? So now you have a continuum of options for file system access across parallel file systems, POSIX, NFS, and object storage to choose from across your portfolio. I mentioned Cyberhaven in ARC 200 is a session there. If you look at ARC 208, these are some other sessions of interest. ARC 208 is going to be talking about cloud storage and Fuse in more detail, and Codeway is going to be co-presenting there. Codeway, for those that aren't familiar, have a generative AI model for avatars. They use GKE, cloud storage Fuse to do this, and they've been able to ramp up to millions of users seamlessly. So you can hear more about Codeway in that one. Hyperdisk, the persistent disk I mentioned with GKE, ARC 219. Ruben Hess is going to be leading that one. Hyperdisk is our next generation block storage. And then a little more detail on Filestore as well as NetApp volumes in ARC 220. And then lastly, ARC 217 in the lower left there for the high performance computing. That will go into more details about parallel store and some of the specific testing metrics that we have there. So there'll be many more details in those breakouts. Lastly, I wanted to ask everybody, just remind, if you have a chance, fill out the survey form. It'd be great to get your feedback for that session so we can always improve upon that. And with that, I'd like to thank everybody for attending.